So hey, what's up guys, this is T59 of my DSA challenge, and today I did a question from the driver's A to Z sheet. It was pretty hard to understand and solve it. So the question was to minimize the maximum distance to the gas station. So in this question, we are given a sorted array of size n containing integer positions of n gas stations on the x-axis and an integer k. So we have to place k new gas stations on the x-axis with the provided info on the current gas stations present. So the new gas stations can be placed anywhere on the non-negative x-axis, so positive x-axis, including non-integer positions. So we can place it at any decimal value. It could be accepted. And let distance be the maximum distance between adjacent gas stations after adding the k new gas stations. So find the minimum value of distance. If we take the example, here there are 10 currently 10 positions of the gas stations, and the positions are 1 to 10, and the value of k, which is the number of gas stations, so we have to add more are 10. So how are we going to add them? So there are actually multiple ways to add it, but we have to find the minimum distance between the adjacent gas stations of all of them. So if we place a gas station at 0.25 and another at 0.5 and then 0.75, if we do like that, so the gas station we can place between two contiguous numbers is 3. So one at 0.25, second at 0.5, and third at 0.75. So 3, and we have to place 10 total, in total 10. So we can do it like 3 times it will be 9, and in between 4 and 5 we can fit 1, and in that we would be fitting in like almost 10 gas stations. But the minimum value between all of them must be that same value. But here in this case we are only doing it till 5, and after that 5 all of them have the minimum distance between them as well, so it is not valid. And in this case, the answer will be like, first we are going to place at 1 and then 1.5, 2, 2.5. So in that manner, we are placing 10 actual values in between them, and the minimum distance between them is 0.5. So that's how the question is. It is kind of complicated to understand at first. Even I wasn't able to understand it properly. I did many test cases on it and then was able to understand. So first we are going to find, let us set the boundary limits, low as 0 and high as 1. We are not going to use the simple binary search, which is like low less than equal to high. So first we are going to find the high value. High will be the max distance between any two numbers. The main problem we have to do is that first find the maximum distance between the contiguous numbers. So in this case, all of them had the same value, but in other cases it would be different. So first find the maximum distance between any two numbers. So that will be our high value. And after that, we are going to define the difference, which is 10 to the power minus 6. So high minus low must be greater than 10 to power minus 6. If it is, like, it will keep going on till infinite and the loop will never stop. So that will give us time limit exceeded warning. So that isn't quite good. So the maximum value we can take is the minimum value we can take is 10 to the power minus 6. After that, it will be 10 to the power minus 7. Like, that will be very huge values. So we are going to avoid it and take only till the 10 to the power minus 6 values. So first find mid, which is a loop plus I by 2, and we are going to name this variable as count, and it will be taking the output of the function, which is going to find this number of gas stations we can place in that gap. And if the count is greater than k, the number of gas stations we have to place, then we would do low equal to mid or else high equal to mid, and at last we are going to return high. So in this number of gas stations required, we are giving the parameters as distance and array. So first we are going to declare count as 0, and using for loop we are first going to find the gap. Gap will be like the current element minus its previous element. So we are starting from 1, so it will be array of 1 minus array of 0, and the numbers we can place in between them is the gap divided by its distance. So distance is, in this case, it is mid value. So the mid value we are going to pass is going to define how much numbers we can fit in between. And in case if the gap is equal to a number in between, like if it is perfect number, it is not a double value or like decimal value, then first we are going to like decrement the number, and then we are going to add it in count, and at last we are going to return the count. So that's how the solution looks.